right, just got cut off. So here we go with part two. So let's grab the pen and figure out where we were. I think we're ready to go. But all right, so we're talking about this opposite reciprocal. So if these two adjacent sides have opposite reciprocals, which means you got to be able to flip the fractions and you got to change the sign so that fits. That means you got a right angle. Same thing happens with these two adjacent sides. These two adjacent sides, you got -1 and 1, so again, right angle. And these two adjacent sides, you got 1 and -1, so again, right angle. So therefore, you have just shown this quadrilateral has 4 right angles, and therefore it must be a rectangle. And going back to the problem before this, remember this. If these two opposite sides have the same slope, they're both -1s, they're parallel. So you can put arrows in there, and then you got these two sets. So this is definitely a parallelogram, but when a parallelogram gets 4 right angles, that means it becomes a rectangle. Okay? So I'll go ahead and put that too. Is a parallelogram with the important part, 4 very right angles. All right, so rectangle. All right, let's move on to the main event. Here we go. Example number 3. Determine whether the following shape is a parallelogram or a rectangle. So they get the visual here, so we can do the slope triangles if you want to go visual, or they give you the points right off the bat, the ordered pairs, so you can throw them in the formula pretty easy too. So they're going for the slopes here, so let's just go ahead and do that. Tell you what, I may go with the slope triangles because I'm just a big fan. Or you know what? Hang on a second. The scale's going by 2s, so that may throw some people off. So be wary of this. Always double check your scale. So maybe I should have gone with a formula, but let's just see if this works. So here we go. Top side, I'm going to make a right triangle. And to get the rise and to get the run, I'm actually going to look at the ordered pairs too. So look at this. If you're doing the vertical, look at your y coordinates. You're going from a 5 up to a 14. So what's that total distance? 14 minus 5 is going to be up 9. All right, and just run with that. Now we're going to go to the run. So let's look at the x coordinates. You're going from a 0 to a 10. So that means you're going to the right 10 places. All right. So if you're going for the slope, that means you definitely have rise in 9 over the run in 10. All right, that worked. So let's move on to the opposite side. Let's see if the same thing happens down here. So let's connect this. Oops, no line. So we're going rogue. All right, here we go. To get the rise and run, let's look at these coordinates again. I'm going to start over here at B. You're going from, let's go across. So let's do the x's. X's go across. So you're going 5 to 15. So it's 15 minus 5. It's going to be 10. And then we're going to do the vertical. So let's look at the y. So you're going from a 0 up to a 9. So that's just the automatic 9. So slope of this side is going to be rise 9 over run 10. So that's looking pretty good. So I'm going to go ahead and mark these. You got at least one set of parallels. Let's keep scoring home here. So was that AC to CA is going to be 9 over 10. And then we got what BD, same thing, 9 over 10. Change up the color. Let's go blue. All right, let's start down here. So let's connect these 2 points with a slope triangle. A little messy. All right, let's see here. The run, you're going from a 0 to a 4, so that's automatic. Oh, wait, no. You're going from a 0 to a 5. Watch for that. Ooh, see how fast that can happen? Now, on this one, you're going 0 to a 5, so that's a 5 as well. So the slope of this one's going to be 5 over 5, which is just 1. Okay, so that was what? B and A, so AB, so the slope of that one is 1. All right, let's do the opposite side of that one. So we're going to go over, we'll come straight down to D, forming that right angle. All right, let's do the extras. We're going across here. So we're going from a 10 to a 15, which means you're going a total of 5. Y's, you're going from a 14 down to a 9. So 14 minus 9 is a 5. Ooh, you know what? I just forgot. And this is worth a whole nother color. All right, watch out for this. Oops, let's go green. If you're doing distance, which I've used a slope triangle for distance before, if you want to know how long this side is, you could just do the Pythagorean theorem. Do 5 squared plus 5 squared equals c squared, and you get that length real fast. So if you ever want to know if opposite sides are congruent, you can use the Pythagorean theorem with these lengths. But remember, if you're doing slope now, slope's direction. So let's say I started A and I went down this way. That means this is a -5 direction. And then you go to the right, which is a positive. So remember slope's direction. And then any line that goes down to the right should be negative. So let's see here. The rise should have been -5 over +5, which should be a -1. So I'm glad we caught that. Let's go back over here and change that while we're thinking about it. -1. It does make a difference. Okay. So let's go back over here. So see, we're going to the right, that's a +5, but then you're going to go down, so that's going to be a -5. So when you write the slope, it's going to be vertical, which is your -5, over your horizontal, which is your 5, and that is also going to be -1, which is good. So slope of this one is -1. And these two opposite sides have the same, so I'm going to put my arrows in there, because I just like making arrows. All right, so that means DC was -1. So here we go. It's definitely a parallelogram to start with because you got opposite sides of parallel. And you could also say opposite sides of parallel and congruent again, because if you make a right triangle and do 9 and 10, 9 squared plus 10 squared equals c squared, you're going to get a distance here. And if you use 9 and 10 down here, you're going to get the same distance. So you can go ahead and say opposite sides are parallel and congruent just by doing these slope triangles. And then same thing down here, you got a 5 by 5 and a 5 by 5, which means these two lengths will end up being the same if you plug those lengths into the Pythagorean theorem. But if we're just going by slopes, we got opposite sides are parallel, which is a parallelogram. But let's see here. If it's going to be a rectangle, remember, rectangles got to have right angles. And it needs 4 of them. So we got to check for opposite reciprocal slopes with those adjacent sides. We need to know if we're going to have right angles. So 9/10 versus -1/1. I'm going to write it up here. You got, oops, that's a positive 9/10. You got 9/10 versus -1/1. Do these look like they're going to be opposite reciprocals? I'm going to put a big question mark. So yeah, it's not even close. If you flip this, you get 10/9. Not even close. So that's a big no all day long. So what does that mean for us? It means we do not have a right angle. And down, same thing down here. Those are not opposite reciprocals. Those are not opposite reciprocals. Those are not opposite reciprocals. So you have no right angles. So therefore, this is just a parallelogram. It's close. Look like it wanted to be right angles, but going by the math, those are not opposite reciprocal slopes, so we cannot call it a rectangle. So therefore, again, we have just a parallelogram. And that is it, folks. Hope you're doing all right. Hope you enjoyed your spring break. There will probably be a lot more videos coming soon because some of these are going to get fairly technical. But all right, this is Coach Lowe. I am signing out. Part 2 of using slope to classify your quadrilaterals. All right, see you.